Hello and welcome to the first class on periodic classification and periodic properties. As we had seen in atomic structure, we tried to see the microscopic aspect, the quantum mechanical aspect inside an atom, which are mathematical in nature, but we learned the four different quantum numbers, the shapes of orbitals, the signs of lobes, how many lobes are present in which orbitals, and the nodes, those are present in orbitals, the radial node, the angular node. We also saw how photoelectric effect proved the dual theory of light or other electromagnetic radiation. Also, we saw in a very qualitative manner blackbody radiation, how the lambda max value shifts to the lower wavelength region and its left leg enters into the visible UV region, so that it starts uh, emitting light from red to yellow to finally white, or blue is white. And Wien gave a displacement law, how it displaces, how it depends on temperature. It doesn't depend on any other factor. The composition of that black body. No one is 100% black body, but there are some black bodies which are more than 90%. They can be studied, and their graphs are all same, almost same, if the temperature is constant. Sun is an approximate black body, stars, Earth itself is a black body. Every metal can be thought as an approximate black body. So today we are starting a new topic, which is not new to you, particularly to some of you. But yes, we have to go further into the subject. But as a matter of routine, we have to sing the song. And guys, you have to draw the table in my presence. What you draw, don't use scale. Use your free hand to draw seven and make a landscape, not in portrait mode. Make your copy in a landscape mode like this. Not like this, but like this. And draw six lines, so that you will get seven. Uh, 1, 2, 3, 4, 5, 6, 7. From one end to the other end. And first draw two groups in the left portion. We know the S block. This is group 1 and 2. Previously called 1A, 2A. You must also know its old nomenclature. Sometimes it is uh, helpful. It will be helpful. So 1 and 2. And then leave a big portion in the middle and start towards the end, so that we can draw six columns, six groups. So I'm unable to draw straight lines, but which you can do. 1, 2, 3, 4, more or less approximate. Like blackboard is approximate, blackboard is approximate straight lines. You do not have to use scale. 1, 2, 3, 4, 5, 6. This is group 13, 14, 15, 16, 17, 18. Then this is period 1, period 2, period 3, period 4, period 5, period 6, period 7. These are groups. This is 1A, 2A, and this is 3A, 4A. 5A, I'm sorry, 5A, 6A, 7A, and this was called 0. Now it's called 18. And now from the fourth period downwards, you draw, from fourth period downwards, you draw 10 columns. I'm sure some of the space will be lying vacant for group 12. So it doesn't matter if more space is left out for group 12. 1, 2, 3, 4, 5, 6, 7. Oh, 7 cannot be tolerable. 7, 8, 9, 10. So this group 1, 2, 3, 4, 5, 6, 7, 8, 9. This space is dedicated to the nation. I got an extra space. I could have made a big group, a big, column. So this is rejected. That is why I told you don't use any scale. It will take a long time. We don't need that. So I have drawn 10 columns. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we connect it to 13. And earlier it was called 3B. These are the B groups. 4B, 5B, 6B, 7B, 8. The 8, 9, 10 combinedly was called 8. There is no B or A. Combinedly, the three groups, columns were called 8 group. And this is 1A, the coinage metals. This is, sorry, 1B, I'm so sorry. 1B, and this is 2B. This is the long form of the periodic table. I'm not going to talk about the history of periodic table. You can watch my videos where I have made multiple videos on history of, because from last year we have started to observe periodic table day. And maybe that was observed in Bismay school on February 7th. Am I correct? No, 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 no. February 7th, I observed here online, which
Sir,
perhaps,
after March 7.
huh?
After March 7.
Yeah. February 7th, I observed here in online, which perhaps that video Swayam has had watched. But after their examination on March something, uh, it was observed again in their school and in some Sundargarh district, some school. I think I have done it in 3 schools. Maybe coming year, I'll be selecting a few more schools, and every year we'll be doing that during that period. Or maybe in other periods also. A long form of periodic table, PT, periodic table. And now let us put two rows at the bottom for the lanthanides and actinides. Ln, N. We'll be doing everything now because we have already included 118 elements in our song, so we have to do all. We are not class 9 students, we will know all of them. So let's start. Hydrogen, helium. You can yourself chant, or you may not. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Number 10. Let's write down. This is the atomic number 10. Then enter into third period. Sodium, magnesium, and there is nothing in the third period also. Say first, second, third period, there is nothing in the D block. I mean, this combinedly is called the D block, as you know, or the middle portion. And this is called the S block. And the right portion combinedly called the P block. All the 6 groups. Now sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, 18. सरला 5 मिनट भितर सारदा. If you are becoming slow, you can have your, if you have a printed periodic table with you or somewhere you find the periodic table, you can keep it in front of you if you want. But once we draw the periodic table, all elements, so that will be your periodic table. No need, you can refer that periodic table again and again. Then comes to fourth period. Potassium, calcium. Then my melody has changed. Scandium, titanium, vanadium, chromium, manganese, Mn, iron, Fe, cobalt, nickel, copper, zinc. তারপর পুଣି একা মেলোডি পুଣି পি ব্লକରେ gallium, germanium, arsenic, selenium, bromine, krypton, 36, potassium, calcium. তারপর ଟିକେ ମ୍ୟୁଜିକ୍ ଅଛି 4ଟା ବିଟ୍ସ. ସ୍କାଣ୍ଡିୟମ, ଟାଇଟାନିୟମ, ଭ୍ୟାନାଡିୟମ, କ୍ରୋମିୟମ, ମ୍ୟାଙ୍ଗାନିଜ, ଆଇରନ୍, କୋବାଲ୍ଟ, ନିକେଲ, କପର, ଜିଙ୍କ, ଗାଲିୟମ, ଜର୍ମାନିୟମ, ଆର୍ସେନିକ, ସେଲେନିୟମ, ବ୍ରୋମିନ, କ୍ରିପ୍ଟନ, 36. ସରିଲା? ଆରେ ସରିଲା କି ନାହିଁ? ମୁଁ କଣ, ତୁମେ ଅଛ ନା ମୁଁ କାହାକୁ
ଆଜ୍ଞା ଆଜ୍ଞା ସାର୍
ପବନକୁ କହୁଛି? ଶୂନ୍ୟ ତ ଏଠି ନାହିଁ, ଆମେ ଶୂନ୍ୟ କହୁ, କିନ୍ତୁ ଦେଖିଲା ବେଳକୁ ଏୟାର ଏଠି ଅଛି, ବାୟୁ. And in our Hindu religion, we take the air as a god. Batadev, Bata. Apa hela water. Bhishma is a Veda specialist. Apa, Bata hela air. Please correct me if I am wrong, Bhishma. And Arkadev hele Agni. And Agote rohile kiye na Surya Dev. So there are many devatas. Out of them, the 4 are, they can be experienced, they can be felt. Sun God, Surya Dev, Bata Dev, the air that we breathe in, which sustains our life. And without water, nothing is possible. Our life is also untenable, impossible without water. So Apa Dev, and Arka. We are alive because we carry heat. The moment we lose the heat, we are no more. The heat is an important ingredient of nature, which we may worship as God. Then asla 5th period. Rubidium, strontium. Then asla D block, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium भी କହିପାରିବ, palladium, PD, silver, cadmium. Then चलला indium, tin, antimony, tellurium, iodine, xenon, 54. এটি 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 2 ଥିଲା, ହିଲିୟମଟା 2 କରିଦିଅ, ଏଠି 8 ବଢ଼ିଲା, 8 ବଢ଼ିଲା. ତାପରେ ଯେହେତୁ ଡି ବ୍ଲକରେ ଆରମ୍ଭ ହେଇଗଲା ଆଉ ଏକ୍ସଟ୍ରା 10ଟା, ତେଣୁ 10, 8, 18 ବଢ଼ିଲା, 18, 18, 36. ସରିଗଲା? ସିଜିଏ
ଆଜ୍ଞା ସାର୍
ଇଏ ବିସ୍ମୟ ସରିଲା? ସରପ୍ରାଇଜଡ?
Yes, sir.
ସରିଲା? ଦେନ୍ ଆସିଗଲା ସିକ୍ସ ପିରିୟଡ଼ ସିଜିୟମ୍ ବେରିୟମ୍। ତାପରେ ୟୁନୋ ଆସିଗଲା ତଳକୁ ପଳେଇ ଆସିବା। ଆଜିକାଲି ଆଉ ଏଠି ଏଠି ଗୋଟେ ଷ୍ଟାର ମାରିଦେବା, ଆଜିକାଲି ସେଠି ରଖୁନାହାନ୍ତି। ଏଇ ଜିନିଷଟାକୁ ଆମେ 15ଟା ଏଇଠି ଲେଖିବା। Lanthanide starts. Lanthanide element starts. Lanthanum, cerium, presodimium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, জায়গা হেলানি, lutetium। Lanthanum, cerium, presodimium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, সরিলাকি ବିସ୍ମୟ ବାବା ସ୍ୱୟଂଜିତ
ଆଜ୍ଞା
ବାବା।
ସାର୍।
ବ୍ୟାକ୍ କରିବା।
ଆଜ୍ଞା ସାର୍।
ପୁଣି ଆଉଥରେ ଲାନ୍ଥାନମ୍ ମୋତେ କହିବାକୁ ପଡୁଛି, କାରଣ ସେଇ ଏକା ମେଲୋଡିରେ ପଡ଼ିବ। ଲାନ୍ଥାନମ୍, ଏ ଯେମିତି ସ୍କାଣ୍ଡିୟମ୍, ଟାଇଟାନିୟମ୍, ଏଠି ଲାନ୍ଥାନ ଲେଖିବାନି, କିନ୍ତୁ କହୁଛି ଲାନ୍ଥାନମ୍, ହାଫନିୟମ୍, ଟାଣ୍ଟାଲ, ହାଫନିୟମ୍ଟା ଚଢ଼ିଗଲା। ଲାନ୍ଥାନମ୍ଟା ଖାଲି କହିଲି କିନ୍ତୁ ଲେଖିଲିନି। ଆଗରୁ ଲେଖା ହଉଥିଲା ଏଇଠି, ଏବେ ଲେଖା ହଉନି। Lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, iron, cobalt, ruthenium, rhodium, osmium, iridium, platinum, gold, mercury। তারপরে চাললা থালিয়াম, লেড, বিসমাথ, পোলোনিয়াম, অ্যাস্টেটিন, রেডন, 86। সিক্স পিরিয়ড সরলা। ଆରେ ଇଏ କ'ଣ ପଳେଇଲାଣି? ତାର ନେଟୱାର୍କ ଏମିତି ସିରିୟସ୍ ପ୍ରୋବ୍ଲେମ୍ ହେଉଛି, ସେ ମଝିରେ ମଝିରେ ପୁରା ଡିସ୍କନେକ୍ଟେଡ୍ ହେଇଯାଉଛି। କ'ଣ କରିବା? ସେଇଟା ତ ଆମ ହାତରେ ନାହିଁ। ମୋର ଯଦି ଖରାପ ହେଇଯିବ, ଇଣ୍ଟରନେଟ୍ଟା ପ୍ରୋବ୍ଲେମ୍ ହେବ, ବ୍ରଡ଼ବ୍ୟାଣ୍ଡ, ତାହେଲେ ତ ନିଶ୍ଚୟ କ୍ଲାସ୍। ମିଷ୍ଟର ତ୍ରିପାଠୀ, ତମର ବୋଧେ ନେଟୱାର୍କ ପ୍ରୋବ୍ଲେମ୍ ହେଉଛି ନାଇଁ?
ଆଜ୍ଞା ସାର୍।
ଓକେ, ସିକ୍ସ ପିରିୟଡ଼ ସାରିଲେଣି, ଇନକ୍ଲୁଡିଂ ଲାନ୍ଥାନାଇଟ୍ସ?
ଆଜ୍ଞା ସାର୍। ଆଜ୍ଞା ସାର୍।
Seventh, let's go to the seventh period.
ଆଜ୍ଞା।
Lithium, francium, radium, francium, radium. It would a double star, it would a single star connecting. It double star कर दो, ये double star connection कराला। फ्रेंसियम, रेडियम, फ्रांसियम, रेडियम, तापर एक्टिनेट्स आसिला। एक्टिनियम, थोरियम, प्रोट्रैक्टोनियम, यूरेनियम, नेपटूनियम, ठीक तौल लिखते हो, नेपटूनियम, प्लूटोनियम, एमेरिसियम, एम। यूरोपियम तले जमी एमेरिसियम पड़ो, एमेरिसियम, एक्टिनियम, थोरियम, प्रोट्रैक्टिनियम, यूरेनियम, नेपटूनियम, प्लूटोनियम, एमेरिसियम, क्यूरियम, बर्केलियम, कैलिफोर्नियम, आइंस्टाइनियम, फॉर्मियम, मेंडेलिवियम, नोबेलियम, लॉरेंसियम। actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, formium, mendelevium, nobelium, lawrencium. ହେଲା LR
ଆଜ୍ଞା ସାର୍ ସଇଲା।
ଦେନ୍ এইটা যদিও বিশেষ କିଛି ଏଗୁଡ଼ା ସବୁ ସିନ୍ଥେଟିକ୍ ହେଇଗଲାଣି ତଥାପି ଆମେ କରିଦେବା। ପୁଣି ଆଉଥରେ ମୁଁ ଆକ୍ଟିନିୟମର ଉଚ୍ଚାରଣ କରିବି। ସେମିତି ସ୍କାଣ୍ଡିୟମ୍, ଟାଇଟାନିୟମ୍, ସେମିତି ଆକ୍ଟିନିୟମ୍, ରଦରଫୋର୍ଡିୟମ୍, ଡବନିୟମ୍, ଡିବି ଜାଗା ହେଲାନି ମୋର, ଡିବି, ଡବନିୟମ୍, ସିବୋର୍ଗିୟମ୍, ଏସ୍ଜି, ବୋରିୟମ୍, ଯେମିତି ରେନିୟମ୍, ଟେକ୍ନେସିୟମ୍, ଭୋରିୟମ୍, Hassium, Mittenarium, Dumpstartium, DS, Roentgenium, RG, Roentgenium, Copernicium, gold, mercury, silver, cadmium, copper, zinc, Roentgenium, Copernicium, তারপরে নিহোনিয়াম, ফ্লেরোভিয়াম, মস্কোভিয়াম, লিভারমোরিয়াম, Tennessine Organization 118 সল্লা actinium, rutherfordium, dubnium, seaborgium, borium, hassium, mittenarium, dumpstartium, roentgenium, copernicium, nihonium, flerovium, moscovium, livermorium, Tennessine Organization 118 ହେଲା।
ଆଜ୍ଞା ସାର୍ ସଇଲା।
ନା ମୁଁ ତୁମେ ପେନସିଲ କି ପେନ୍ ଚେଞ୍ଜ କର, ଯଦି ବ୍ଲୁରେ ଲେଖୁଛ ରେଡ୍ ନିଅ, ମୁଁ ରେଡ୍ରେ ଲେଖୁଛି, ବ୍ଲୁ ନେଉଛି। ଟୁ ଡ୍ର ଦି ଷ୍ଟେୟାର ଷ୍ଟେପ୍ ପାହାଚ ରନିଂ ବିଲୋ ବୋରୋନ୍, ଗୋଟେ ହରିଜଣ୍ଟାଲ ଗୋଟେ ଭର୍ଟିକାଲ, ଗୋଟେ ହରିଜଣ୍ଟାଲ ଗୋଟେ, ତ ତମର ଯଦି ଅନ୍ୟ କଲର ନାହିଁ ସେଇଠି ଟିକେ ଗାଢ଼ା କରିଦିଅ, ବୋଲ୍ଡ କରିଦିଅ, ଯେଉଁ ଜଣା ପଡ଼ିଯିବ। ଆଉ ତଳକୁ ନେବା ଦରକାର ନାହିଁ, ଏତିକି ନେଲେ ଯଥେଷ୍ଟ। ଏଇଟା ହେଲା ଡିଭାଇଡିଂ ଲାଇନ୍ ବିଟୱିନ୍ ମେଟାଲ୍ସ ଆଣ୍ଡ ନନ୍ ମେଟାଲ୍ସ। ବାଁ ପଟେ ସବୁ ମେଟାଲ୍ସ ଆଣ୍ଡ ଡାହାଣ ପଟେ ସବୁ ନନ୍ ମେଟାଲ୍ସ। ତା ଭିତରେ ଯେଉଁଟା ଲାଗିକିରି ଅଛି ସେଗୁଡ଼ାକ ହେଲା ମେଟାଲଏଡ୍। ବୋରନ୍ ହେଲା, ଆଲୁମିନିୟମଟା ଏକ୍ସେପସନ୍, ମାନେ କଟ୍ଟର ମେଟାଲଏଡ୍ ହେଉଛି ଏଇଟା, ସିଲିକନ୍, ଜର୍ମାନିୟମ, ଆର୍ସେନିକ୍, ଆଣ୍ଟିମନି, ଟେଲୁରିୟମ୍, ଏମାନେ ହେଲା କଟ୍ଟର। ତା ଭିତରେ ଆଜିକାଲି ମେଟାଲଏଡ୍ ଭିତରେ ଇଭେନ୍ ଆଲୁମିନିୟମଟା ବି ପୁରଉଛନ୍ତି, କାର୍ବନ ବି ପୁରଉଛନ୍ତି, ଆଉ ଆଉ କେଉଁଟା ପୁରଉଛନ୍ତି, କାର୍ବନଟା, ଆଲୁମିନିୟମଟା, ଏସବୁ ଆସୁଛି। ମୋ ନୋଟ୍ସ ଦେଖିବ। ଏବେ ଦେଖେଇ ଦେଉଛି ତୁମକୁ। ଆଜିକାଲି ଏ 7ଟା ଥିଲା ଯେଉଁ ଏଇଟା ତ ହେଲା, କିନ୍ତୁ ଏବେ କଟା ହେଇଗଲା। କିନ୍ତୁ ଆଉ ଗୋଟେ କେଉଁଠି ଥିବ, କିନ୍ତୁ ଆଉ ଗୋଟେ କେଉଁଠି ଥିବ, ଯେ କେଉଁ ଜାଗାରେ ଗୋଟେ ଥିବ, ମୁଁ ଦେଖେଇବି ତମକୁ। ସବୁ ଡିସ୍କସନ୍ କରିଛି। ନା, ସୋ ଏଗୁଡ଼ାକ ମଧ୍ୟ approximately they taken as what for all examination purpose 7ଟା 1 2 3 4 5 6 you can take polonium, astatine, ଏଗୁଡ଼ା କିଛି ମାନେ ନାହିଁ। They are available in scarce quantity in nature. Nowadays, let me remind you that after bismuth, all the elements, I mean, don't disfigure. You can put star mark or any other symbol that will be known to you starting the radioactivity. all elements after polonium, after bismuth, they are radioactive. Up to uranium, naturally radioactive. It would a dividing line दे दियो, change कर दियो. After uranium, ମୁଁ ଗୋଟେ change କରିଦେଲି blue green କରିଦେଲି. These are synthetically radioactive. All are synthetically prepared by nuclear transformation process, the cyclotron device. So ଏଗୁଡ଼ାକ ସବୁ synthetic. କୋଉଠୁ ନା uranium ପରେ. Actually, neptunium, plutonium, they are, to me, they are natural elements because they were there, but now they are almost extinct and we are preparing synthetically. But they are there. Wow, how you know they were there? Because they are descendants. ଯେମିତି ବିଷ୍ମ ତ୍ରିପାଠୀ ହେଲେ କାହାର ଭରଦ୍ୱାଜ ନୁହଁ ମ, ତମର ଗୋତ୍ର କଣ? ବିଷ୍ମ, ତମେ ଯୋଉଥିରେ କୋର୍ସ କରିଛ ମ, ଶ୍ୟାମ ଯଦୁର୍ବେଦ, ତମେ କୋଉଥିରେ କୋର୍ସ କରିଛ? ଇଏ ତାକୁ ଶୁଭୁନି, ମୋଷ୍ଟ ଲାଇକଲି ସେ ବୋଧେ ଦେଖିବ, କାରଣ ସ୍ୱୟଂ କେତେଟା ବେଦ ଅଛି ଆମର?
Sir, ଚାରିଟା.
କଣ କଣ?
Sir, ଋକ୍, ସାମ, ଯଜୁର, ଅଥର୍ବ.
ଚାରିଟା ଏବେ ତ ତିନିଟା କହିଲ, ଶ୍ୟାମ ଯଦୁର୍
ନାଇଁ sir, first ଟା ଋକ୍ କହିଲି.
ରୁକ୍ ସାମ ଯଦୁର୍ବେଦ and ଅଥର୍ବ ବେଦ, ନାଇଁ?
ଆଜ୍ଞା sir.
ମୁଁ କାହିଁକି ବେଦ କଥା ଉଠେଇଲି ମୁଁ କିଛି ବୁଝିପାରୁନି, କଣ ପାଇଁ ଉଠେଇଲି କହିଲ? ବେଦ କଥା କାହିଁକି
Sir,
ଉଠେଇଲି?
ଗୋତ୍ର ପଚାରୁଥିଲେ.
କାହିଁକି ପଚାରିବି, ମୁଁ କାହିଁକି ଗୋତ୍ର ପଚାରିବି? ଆଇ ଏମ୍ ନଟ୍
Sir, sir, ନେପଟୁନିୟମ ଆଉ ପ୍ଲୁଟୋନିୟମ ର sir
ହଁ, ତାଙ୍କର ସବୁ, ସେମାନେ ଯଦି ଜଣେ ରୁକ୍ ହେଲେ, ଜଣେ ଶ୍ୟାମ ହେଲେ, ଯଦୁ ହେଲେ, ତାଙ୍କର ସବୁ ଡିସେଣ୍ଡେଣ୍ଟ, ଭୀଷ୍ମ ପିତାମହ, ତାଙ୍କ ଡିସେଣ୍ଡେଣ୍ଟସ୍ ମାନେ ଆଭେଲେବଲ ଅଛନ୍ତି. ଯଦି ତାଙ୍କର ଡିସେଣ୍ଡେଣ୍ଟସ୍ ମାନେ ଅଛନ୍ତି ଆଭେଲେବଲ, ତାର ଆଇସୋଟୋପ୍ସ ଗୁଡାକ they are radioactive, naturally radioactive, ତେଣୁ ସେ ନିଶ୍ଚୟ ଥିବ, ଯିବ କୁଆଡେ? ବର୍ତ୍ତମାନ ବିଲୁପ୍ତ ହେଇଗଲାଣି ଅଲମୋଷ୍ଟ. ନାଉ ବିଲୁପ୍ତ ଭିତରେ ଟେକ୍ନେସିୟମ ରେ ଗୋଟେ ଗୋଲ ବୁଲା, ନ୍ୟାଚୁରାଲ ବଟ୍ ନାଉ ବିଲୁପ୍ତ, ଟେକ୍ନେସିୟମ and ଏଠି ପ୍ରୋମେଥିୟମ. ବିଫୋର 83 ମାନେ ବିସ୍ମତ ପୂର୍ବରୁ ଏ ଯୋଡ଼ିଏ technetium and promethium, they are radioactive naturally, but they were naturally present, but now they are extinct almost. They are being prepared synthetically. But natural elements ଭିତରେ ଆମେ ୟୁରାନିୟମ ପର୍ଯ୍ୟନ୍ତ ନବା, କେହି ମୁଁ ତ କେତେ ଗୁଡ଼ାକ ଜାଗାରେ ପ୍ଲୁଟୋନିୟମ ପର୍ଯ୍ୟନ୍ତ ନେଇଛି 94ଟା. So it is controversial depending on if you include the element having trace abundance, ତାକୁ ଯଦି include କରିବ 94 ଯାକେ ଯିବ. ଏବେ ତ एस्टेटाइन, पोलोनियम एवं फ्रांसियम এটা কোন করতেলে গোল, they are almost extinct. पोलोनियम, रेडन नुहे, रेडन पोल्यूशन तो चली, यूएस इज सफरिंग द मोस्ट. से यूरेनियम तो भर्ती अच्छी, जो यूरेनियम ओर अच्छी, थोरियम ओर अच्छी, सेठी रेडन इज ए बाय प्रोडक्ट इन दैट चेन रिएक्शन. सो रेडनटा फटकिन गैसटा तो से रहुनी, से फटकिन उठी जाउची, घरे बाड़ी रे ये रे सब रेडन उठी जाउची, एंड दैट इज आल्सो रेडियो एक्टिव. हाँ, रेडियो एक्टिविटी गोटे पर्टिकुलर लिमिट रे रहिले किछि असुविधा नाही. आम बॉडी रे मध्य पोटासियम 40 अछि, कार्बन 14 अछि, मु कहउतिली व्हिच आर बीटा एमिटर्स, हमर किछि होउनी. बट जदि हमें बहुत मात्रा रे हमें ये करे रहिबो, हमर tolerable limit ऊपर आसिबो, ताले it is difficult, it will produce harm in the body, but within that nothing will happen. But रेडन रो अमाउंट एते बढ़िलानी, गोटे जगारे यूएस रे इट्स hazardous to the skin and to other lungs because it's a gas going through the other gases like nitrogen and oxygen inside the lungs, and radon is radioactive. It's more quantity of its alpha beta, they will damage our lungs. So lungs cancer, even cigarette ନ ଖାଇକିରି ମଧ୍ୟ lungs cancer ହେଇଛି ଲୋକଙ୍କୁ, ହଉଛି ଲୋକଙ୍କୁ. Okay. And you can use the magic numbers to generate the atomic numbers. 1, 2, helium is 2, that is known. Then second period 3, 4, 5, 6, 7, 8, 9, 10. 10 is there. But then you go down the group. In this block, you go down. And these two, this is called F block. Because as you know, the differentiating electron, the next electron is called the differentiating electron, enters into a F orbital. But there are so many anomalies where you don't find any electron in the F orbital for thorium. And you also get no electron in the F orbital for lanthanum and actinium. Still, these two are the first member of the lanthanide and actinide series respectively. So there is always a controversy even in the West that why not we keep lanthanum here, actinium here? Why to put down? But IUPAC has already recommended, because of the similarity in properties, because they are called lanthanides and actinides respectively, let us put all the 15 elements together at the bottom. And so a connectivity that all the 15 elements of the lanthanides should be present in a one small box, not possible. Therefore, they have been spread out in a row, lanthanides. Same is the case with actinides, AN. कौन प्रणाम प्रणाम कोलानी बिस्मा कोची sir pranam. I'm unable to stay in class because of very bad network problem, so I'll watch the recording. Sorry for this. तुम तो अच्छा हो?
Sir, I guess you're in a option for talking me.
Okay. କିଛି ସେଥିପାଇଁ ତ ରେକର୍ଡିଂ ହଉଛି. So ଏଠି ତମେ we can use the magic numbers for the S block. The magic numbers are 8, 8, 18, 18, 32. 1 8 extra than the P block. 132 less than the P block. So it 3 हेले 8 मिसले 11. आउरी 8 मिसले 19. Then 18 मिसले 37. Then 55 18. दीटा 18. Then last को गोटे 32 is 87. And then same principle can be followed for the second group. But you can continue 11, 12, 19, 20, 37, 38, 55, 56, 87, 88. Now come to P block for giving the atomic numbers. Here the magic numbers are 8, good 8, 18, 18 theta, 32, 32 theta. Because the D block पळे आछि fourth period रू. As a result, गोटे 8 कमी जाउछि, गोटे 32 बढ़ी जाउछि. So this is 5. Add 8, it will be 13. Add 18, 31. Add 18, this will be 49. Then 32, 81. Then 32, 113. Then instead of applying the same rule, you can just follow sequentially in the respective period in the same series. 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 31, 32, 33, 34, 35, 36, 49, 50, 51, 52, 53, 54, 81, 82, 83, 84, 85, 86. 86 already लिखा है. 113, 114, 115, 116, 117, 118. Then you just connect 56, since this will come as 57, write down 57, but it is absent here. 8 to 57, 58, oh 8 लिखा पड़ा, 57, 58, 59, 60, 61 होची promethium, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71 lutetium. Then back to pavilion, 72 hafnium, 73, 74, 75, 76, 77, 78, 79 and 80. ଏଥିରେ କନେକ୍ସନ୍ ହେଇଗଲା 81. ଆଚ୍ଛା ଏଇଟା ଭୁଲି ଗଲି କରିବାକୁ ଯେ ଏଇଠୁ ଯୋଉ 20ରୁ 31 ଏଇଠି ସିରିଆଲି କନେକ୍ସନ୍ କରିଦିଅ, ତାର କିଛି ମ୍ୟାଜିକ୍ ନମ୍ବର ଦରକାର ନାହିଁ। 20ରୁ 30 ପର୍ଯ୍ୟନ୍ତ କରିଦିଅ, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 ସେମିତି କନେକ୍ସନ୍ କରିଦିଅ। 39ରୁ 48, 39, 40, 41, 42, 43, 43ଟା ହେଲା ଟେକ୍ନିସିୟମ୍ that is radioactive, 44, 45, 46 ହେଲା palladium ଯାହାର S ରେ ନାହିଁ 5s0 ଅଛି, 40, 47 is silver, 48 ହେଉଛି cadmium। ତାପରେ କିନ୍ତୁ 56 ପରେ 57ଟା ତଳକୁ ଆସିବ 71 ପର୍ଯ୍ୟନ୍ତ, ଦେନ୍ 72 to 80, ଦେନ୍ ସେଇଭଳିଆ 88 ପରେ ଏଇଠି 89 ଲେଖିଦିଅ, କିନ୍ତୁ ଆକ୍ଚୁଆଲି 89 ଏଠି ଲେଖିଛି 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, century, century 1, century 2, century 3. Then come back to Rutherfordium, century 4, 105 डबनियम, 106, 107, 108, 109, 110, 111 रोएंटगेनियम, कोपर्निशियम 112, 113 already ଅଛି। So you can practice maybe 1 or 2 times at home. ତମେ ଯଦି ଗୀତ ନ ମନେ ପଡୁଛି, you can also remember group wise। ମୁଁ କେତେ ଆଗରୁ ମୁଁ group wise ମନେ ରଖୁଥିଲି। ଗ୍ରୁପ ୱାଇଜ ଏବେ ବି କହିଦେଉଛି, ସବୁ ଗ୍ରୁପ ତ ମନେ ରଖିବାକୁ ପଡିବ। ଲିଥିୟମ, ସୋଡିୟମ, ପୋଟାସିୟମ, ରୁବିଡିୟମ, ସିଜିୟମ, ଫ୍ରାନ୍ସିୟମ, ବେରିଲିୟମ, ମ୍ୟାଗ୍ନେସିୟମ, କ୍ୟାଲସିୟମ, ଷ୍ଟୋନସିୟମ, ଏ ସିକ୍ୱେନ୍ସରେ ମନେ ରଖିଦେଲେ ବି ଚଳିବ, ଗୀତ ମନେ ରଖିବା ଦରକାର ନାହିଁ। କ୍ୟାଲସିୟମ, ଷ୍ଟ୍ରଣ୍ଟିୟମ, ବେରିୟମ, ରେଡିୟମ, ଏପଟେ ପି ବ୍ଲକ, ବୋରନ, ଆଲୁମିନିୟମ, ଗ୍ୟାଲିୟମ, ଇଣ୍ଡିୟମ, ଥାଲିୟମ, ନିଓନିୟମ ମୁଁ ପଚାରିବି ଗ୍ରୁପ ୱାଇଜ। କାର୍ବନ, ସିଲିକନ, ଜର୍ମାନିୟମ, ଟିନ୍, ଲେଡ୍, ଫ୍ଲୋରୋଭିୟମ, ନାଇଟ୍ରୋଜେନ, ଫସଫରସ ଗ୍ରୁପ 5, ग्रुप 15 ग्रुप 5A, नाइट्रोजन, फॉस्फोरस, आर्सेनिक, एंटीमनी, बिस्मथ, এইটা কো মনে রাখা দরকার। নিওনিয়ম, সরি নিওনিয়ম, প্লেরোভিয়ম, মস্কোভিয়ম এটা মনে রাখলে ভালো। অক্সিজেন ফ্যামিলি চালকোজেন্স তাକୁ କହନ୍ତି, ନାଇଟ୍ରୋଜେନ ଫ୍ୟାମିଲିକୁ ନିକୋଜେନ୍ସ କହନ୍ତି, ପି ରହିବ ସାଇଲେଣ୍ଟ। ଅକ୍ସିଜେନ, ସଲଫର, ସେଲେନିୟମ, ଟେଲୁରିୟମ, ପୋଲୋନିୟମ, ଲିବରମୋରିୟମ। ହାଲୋଜେନ ସେମାନଙ୍କୁ କହନ୍ତି ଫ୍ଲୋରିନ, କ୍ଲୋରିନ, ବ୍ରୋମିନ, ଆୟୋଡିନ, ଆସ୍ଟେଟିନ, ଟେନେସିନ, and these are the noble gases: helium, neon, argon, krypton, xenon, radon and organeson. You need not write anything. Everything I will give you the file. You know everything. Now these are this is the boron family, 13 carbon family, 14 nitrogen family or the nicogens. This is primitive names. They were called pnictides, the nicogens. These are the chalcogens, the primitive names. And these are the halogens. Halogens is even today popular, but nicogens and chalcogens, these words are not used nowadays. And these are the noble gases. And nowadays it has been found that even bismuth is radioactive. For you I am saying, not for, bismuth is also radioactive. Its radioactivity is so slow that its half-life period is in the order of 10 to the power 13, 15, even more than the age of the earth. So in that case, we regard as virtually stable, but it has been proved with experimental evidence that bismuth is also radioactive. So, and then also you have to remember these transition in series wise as well as group wise. Series wise in the song, scandium, titanium, that way, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, zirconium, niobium, molybdenum, technetium, which is radioactive, ruthenium, rhodium, palladium, silver, cadmium, and this is lanthanum. Forget about it. Lanthanum, you say lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, silver, gold. silver, mercury, gold, mercury. And then here this is actinium, rutherfordium, dubnium, seaborgium, borium, hessium, meitnerium, darmstadtium, roentgenium, copernicium. But group wise also, scandium, yttrium, lanthanum, actinium, titanium, zirconium, hafnium, rutherfordium, vanadium, niobium, tantalum, dubnium, chromium, molybdenum, tungsten, seaborgium, manganese, technetium, rhenium, borium, iron, ruthenium, osmium, cobalt, rhodium, iridium, meitnerium, nickel, palladium, platinum, dumstertium, copper, silver, gold, roentgenium, zinc, cadmium, mercury, copernicium. So, last element you may not, because they are, produced in a very scanty, କାହାର 10ଟା atom, କାହାର କେତେ ମାଇକ୍ରୋଗ୍ରାମ, କାହାର ମିଲିଗ୍ରାମ, ସେ ପୁଣି ତାର ହାଫ୍ ଲାଇଫ୍ ପିରିୟଡ଼ ବହୁତ କମ୍, ସେମାନେ ମରିଯାଉଛନ୍ତି। ଏଗୁଡ଼ା ଖାଲି ଇଏ ଆକ୍ଚୁଆଲି ଆଇନଷ୍ଟାଇନିୟମ ପର୍ଯ୍ୟନ୍ତ 99, ସରି କାଲିଫୋର୍ନିୟମ ପର୍ଯ୍ୟନ୍ତ କିଛି ହାଫ୍ ଲାଇଫ୍ ପିରିୟଡ଼ଟା ଟିକେ ଅଧିକା, ରିଲେଟିଭଲି ଅଧିକା। ସୋ ସମ୍ ମାକ୍ରୋ କ୍ୱାଣ୍ଟିଟି, କିଛି କ୍ୱାଣ୍ଟିଟି ସେମାନେ କରିକିରି ତାର ଫିଜିକାଲ ପ୍ରପର୍ଟି ଷ୍ଟଡି କରିଛନ୍ତି। କିନ୍ତୁ ତା ପରଠୁ ନୁହେଁ, ତା ପରଠୁ ଏତେ କମ୍ ଯେ ସେମାନେ ଫିଜିକାଲ ପ୍ରପର୍ଟି ଷ୍ଟଡି କରିପାରିନାହାନ୍ତି। ମେଲ୍ଟିଂ ପଏଣ୍ଟ ଇଏ ସେ ପ୍ରେଡିକ୍ଟ କରୁଛନ୍ତି, ବିକଜ କ୍ୱାଣ୍ଟମ ମେକାନିକ୍ସ କ୍ୟାନ୍ ପ୍ରେଡିକ୍ଟ କେତେ ହବ, ଯଦି ବଲ୍କ କ୍ୱାଣ୍ଟିଟିରେ ତିଆରି ହବ ତାହେଲେ କେତେ ହବ, ତିଆରି କରୁଛନ୍ତି, ବାରମ୍ବାର ତିଆରି କରୁଛନ୍ତି, ଯେ ମରିଯାଉଛି, କେତେବେଳେ ମାଇକ୍ରୋଗ୍ରାମ, କେତେବେଳେ ମିଲିଗ୍ରାମ, ଏଇ ଟାଇପ୍ର। ୱେଲ୍, ଆ ଭିତରୁ ଗ୍ୟାସ୍ ମାନେ କେତେଟା ନା 11ଟା। ହାଇଡ୍ରୋଜେନ, H2 ଗୁଡ଼ାକ ସବୁ ତ ଏଇ ଯୋଉ 1, 2, 3, 4, 5 ଏଟା ରେଡିଓ ଆକ୍ଟିଭ। 6ଟାକୁ ନେଲେ ବି ଚଳେ। ଅର୍ଗାନିଜମ ଛାଡ଼ ମାର ବୋଲି ତାର 2ଟା ଆଟମ ଆଟ୍ ଏ ଟାଇମ୍ ତିଆରି ହେଉଛି, ଗୋଟେ 2ଟା ଆଟମ ମାର ବୋଲି। ସୋ ଯଦି ଆମେ ରେଡିଓ ଆକ୍ଟିଭ ଗ୍ୟାସେସକୁ ଛାଡ଼ିଦେବା, ରେଡନ୍ ସବୁ ଆଭେଲେବଲ୍ ଇନ୍ ଦି ମାର୍କେଟ, ଆଇ ମିନ୍ ଏଭ୍ରିୱେୟାର। ହିଲିୟମ୍, ନିଅନ୍, ଆର୍ଗନ୍, କ୍ରିପ୍ଟନ୍, ଜେନନ୍, ରେଡନ୍, ଏଠି ଫ୍ଲୋରିନ୍, F2, O2, ଉପରେ O3 ବି ଅଛି ଷ୍ଟ୍ରେଟୋସ୍ଫିୟରରେ, N2 ଆଉ Cl2, ଏମାନେ ଗ୍ୟାସେସ୍। Br2 is a liquid, I2 is a solid, and all others are solids, excepting mercury, which is a liquid, Hg, At, which is a metal. And in African and Asian, hot Asian countries like ours, in the summer season, gallium becomes a liquid. Its melting point is about 29. So it melts on your palm. Even in cold, if you hold gallium in your palm, then it will be looking like mercury, tilting like mercury. And keep it in a bottle or in a container, it will fridge to become a solid. If it is in the cold season, the outside temperature is at 20 or 25, because its melting point is 29, is very close to 30. Therefore, and so also here cesium is about 30 or 29. Don't hold it in your palm, naked palm. Use a glove. Use a glove and then hold. You will find it will be looking like liquid. So Indian and other African nations, they consider cesium and gallium are liquids, along with mercury, which is a metal. Gallium is also a metal. Cesium is also a metal. But bromine is a liquid, which is a non-metal, right? And even 37, rubidium is 37, its melting point is also 37. And in hot, in June, May, June, our temperature exceeds 40, 42, 43. And in Rajasthan, in other countries, it goes sometimes in Delhi, it goes above 45, 47. So then also rubidium becomes a liquid. Francium is also a liquid because it is almost extinct element. Very scarcely found. We are preparing synthetically francium. So the question doesn't arise to melt it. It's still less. It's still less than, if this is about 30, this will be less than that. Its melting point has been studied. No doubt you will get it. And well, let me use what I have left. This file, which I have already shared. Now, the electronic basis of periodic classification we have already done. 1A, they have S1 configuration. This is 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. And this is 2A or 2s2 configuration. Starts from 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. That is why they are called S block, because their last electron enters into an S orbital S1 and this is S2. That is why the properties of the elements belonging to a group are similar. Their oxidation state is +2 here, and for 1 +1, and therefore they have been grouped in the same column. Similarly, you will find in the P block, this will be NS2 NP1. This is 2s2 2p1, this is 3s2 3p1, this is 4s2. Of course, 3d10 will come. 3d10 is not valence shell. When it is complete, it is not a valence shell. It is incomplete, they can be taken as a virtual valence shell. Virtual, not a theoretical. So this is 4s2 3d10 or 3d10 4s2 4p1. This is 4s2 4p 5p1. Sorry, 5s2 5p1, 6s2 6p1, 7s2 7p1. This is p2. The last electron enters into p orbital. This is 2s2 2p2. This is 3s2 3p2. Then 4s2 3d10 4p2. This is 5p2 6p2 7p2. The S will be coming. 5s2 5p2. 6s2 6p2. 4s2 4p2. For the fourth period, then 3d10 will come. From fifth period in the p block, 4d10 will come. The sixth period in the p block, 5d10 will come. So similarly, this is p3 configuration. NS2 NP3. This is 2s2 2p3, 3s2 3p3, 4s2 4p3. Of course, 3d10 will be there. And this is 5s2 5p3, 6s2 6p3, and so on. This is NS2 NP4. All of them have same. This is NS2 NP5. All of them are same. And this is NS2 NP6, excepting helium is only 1s2. So this is the electronic basis. We have done all the electronic configuration with anomalies also in different periods. For example, in first transition series, chromium and copper, they have the Hupfield configuration 4s1 3d5. This is 4s1 3d10. And here in the second transition series, niobium also has, supposing you count down 1 2 3, should have been 5s1 5s2 4d 1 1 2 3 4d3, but actually it will be 5s1 4d4. And as usual, this is Hupfield stability 5s1 4d5. Technetium doesn't have anomaly. Ruthenium has anomaly. You just count 6. Should have been 5s2 4d6, but it will be 5s1 4d7. This is 4d8, 5s1 4d8, and here this is 5s0 4d10. Should have been, if one electron shift would have been happened, then 5s1 4d10, but two electron shift happens here. This is 5s0 4d10, and this is as usual 5s1 4d10, and this is as usual 5s2 4d10. An anomaly in the third transition series happens. Not even tungsten you find any Hupfield stability. Platinum is should be 8 78 8 should have been 6s2 4f14 5d10 5d8, but it is actually 6s1 5d9. Of course, 4f14 has already been filled in the lanthanides before that when you go to hafnium. And gold is as usual 6s1 4f14 and 5d10. Mercury is as usual 6s2 4f14 and 5d10. And then this is p1. Everything remaining same. This is 6p1, 6p2, 6p3, 6p4, 6p5, 6p6. Same thing happens here, but the configurations have not been verified because their amounts are very, only it can be predicted. Oh yes, prediction has been done. No anomaly. Everything goes fine here in the D block as well as in P block. So no, because they don't have any compounds formed to verify the valency, the oxidation state. Only prediction by mathematical calculations, quantum mechanical calculations. Now these things you have to study. I mean, we have done, but I would like to dekhe douchi. left portion, right portion, middle portion. Group 1, sodium, lithium, sodium, potassium, rubidium, cesium, francium. Group 2, the electronic configuration, the valence shell electronic configuration NS1, this is NS2. These things you know. This is boron family, NS2NP1, group 14 carbon family. This is NS2NP2. Then nitrogen family, nicogens, NS2NP3. Of course, from the fourth period, the N-1 D10 will come, but we don't write in the valence shell. If it is complete, it will not take part in any oxidation state. Then 16 chalcogenes, it is NS2NP4, then NS2NP5, the halogens, and noble gases, NS2NP6, except helium. Right? The magic numbers I have already told you. The F block is also called inner transition elements. Transition, within transition, there is another transition. That is why inner transition. Group 3, let us come to the D block. Group 3, the scandium family. Down the group scandium, yttrium, lanthanum, and all the 14 other lanthanide elements, plus 14 other lanthanide elements. So now it should be lanthanum. Plus lekha hai kisi problem nahi. Lanthanum is included. Simply actinium, tar other lanthanide, actinide elements, thorium, tolerancium, total 15टा. ସେମାନଙ୍କର configurations ମଧ୍ୟ ଆମେ ଜାଣିଛେ କୋଉ ଜାଗାରେ anomaly ଅଛି, that also I have told you. In lanthanides ରେ କୋଉଠି ଅଛି, actinides ରେ କୋଉଠି ଅଛି, I have already told you. And also I have written out here. And group 4 ରେ titanium family, titanium, zirconium, hafnium, rutherfordium is synthetically radioactive, and this will be NS2, N-1, D2 anomaly. ଏଥିରେ କିଛି ନାହିଁ, କିନ୍ତୁ 6th 7th period ରେ already hafnium ଆସିଗଲାଣି ମାନେ 4F14 join କରିଗଲାଣି, N-2 F14 will come in the 6th period and 7th period. This you know. 5th period nicogens रे vanadium, sorry, nicogens coach, vanadium family. I'm sorry, P block nahi, D block रे vanadium family, vanadium, niobium, tantalum, dubnium, and एठी मध्य 4S2 NS2 N-1 D3 एठी केवल किंतु नायोबियम रे anomaly अछि, NS1 N-1 D4 हे जाउची है ना अछि. नायोबियम रे एठी anomaly लेखिची, सब जोतरा anomaly अछि जोटा को मेंशन करिची. ग्रुप 6 रे anomaly अछि chromium and molybdenum, ए दीटा. ग्रुप 6 रे ग्रुप वाइज जाउची मु, ग्रुप वाइज एटा तो गला, ग्रुप वाइज chromium, molybdenum, half field stability. 7 रे anomaly अछि कहारो ना ग्रुप 7 रे anomaly नहीं, टेक्नेशियम रो anomaly नहीं, rhenium रो नहीं, बोरियम रो तो सहजे it is a speculative नहीं. ग्रुप 8 रो जोटा को आगुर one of the group columns in the group 8, 9, 10 columns were called group 8 combinedly. The first column sit में लिखी group 8, वर्तमान group 8, iron, ruthenium, osmium, hassium रे. Ruthenium has an anomalous electronic configuration, and others don't have. Similarly, group 9, the second column in group VII, cobalt group जोड़ को कहती, cobalt, rhodium, iridium रे केवल rhodium रो अच्छी anomaly आकार नहीं. Group 10 रो palladium रो अच्छी, nickel, palladium, platinum, palladium रो जबरदस्त anomaly अच्छी, 5s0 40 10. Group 11 रे समस्त कर 3टा जाकर अच्छी, copper, silver, gold, 3टा जाकर anomaly अच्छी, full field stability. Roentgenium is not known, and calculated no anomaly. Calculated no anomaly. Group 12, all field, no anomaly. So there, D block, the differentiating electron enters into the D orbital. But as I have told you that zinc, cadmium, mercury, they are not true transition metals. They do not have any stable ion aqueous solution, any stable aqueous ion having incomplete D subcell. Mercury, they lose electron from the 6s1, 6s0. But D orbitals are not touched in zinc, cadmium, mercury. Though they are not true transition metals, as well scandium. Scandium never loses 2 electrons and leave behind the solitary D1. All 3 electrons go at a time, so scandium has 1 valency plus 3, which yttrium doesn't have. So scandium is not a true transition metal, and all the 3 zinc, cadmium, mercury, they are not true transition, but they are d block elements, no doubt. A block elements, lanthanides and actinides. Lanthanides ভিতরে anomaly ଅଛି lanthanum ନିଜର ସିରିୟମ ସେଇ କଣ୍ଟିନ୍ୟୁ ହେଉଛି 5d1 4f ର ଖାତା ଖୋଲିଲାଣି gadolinium half field stability but d ଅଛି କିନ୍ତୁ actinides ରେ ବହୁତ anomaly ଅଛି actinium ର d thorium ର d f ର ଖାତା ଖୋଲିଲା ନାହିଁ protactinium ର d1 ତାପରେ f ର ଯେତିକି ଦରକାର ସେତିକି ଲେଖିବ ଇଏ ବି ୟୁରେନିୟମ ରେ d1 ଅଛି ନେପଟୁନିୟମ ରେ d1 ଅଛି and ତାପରେ ନାହିଁ ତାପରେ କ୍ୟୁରିୟମ ଯାଇକି ଯୋଉଟା gadolinium ତଳେ half field stability lawrencium ର ଅଦ୍ଭୁତ 7p1 that now it has been revealed that is not having 6d1 rather 7p1 that's the thing that is being observed 7p1 ତାପରେ ପୁଣି ପଳେଇ ଆସୁଛି ଏପଟକୁ ପଳେଇ ଆସିଲା ବେଳକୁ d କୁ ପଳେଇ ଆସୁଛି because once we come back to ଆମର କୁଆଡ଼େ ଗଲା we come back to lawrencium ପରେ ରଦରଫୋର୍ଡିୟମ ଆସିଲା ବେଳକୁ ଆଉ 7p ନାହିଁ d2 କରିବାକୁ ପଡ଼ିବ actinium ରେ d1 ଥିଲା 6d1 6d2 ଚାଲିବ ଆଉ 7 ଏ ଯୋଉ lawrencium ରେ ଯୋଉ ଅଛି କେବଳ lawrencium ରେ ଦେଖାଯାଇଛି theoretically calculation wise କି ଦେଖୁଛି ପ୍ରକୃତରେ କ'ଣ କିଛି experimental compound ତିଆରି ହେଇଛି ଯେ ସେ କହିବ 7p ରେ ଅଛି କି କ'ଣ ଅଛି 7p ରେ ଥିଲେ ହାଇ ଏନର୍ଜେଟିକ ସେ ଆଗ ପଳେଇବ तो कौन देखी थे से लॉरेंशियम रो कौन सी केमिकल प्रॉपर्टी स्टडी है ही नहीं पर फिर भी कंप्यूटेशन करते इन 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 क्वांटम मैकेनिकल मॉडल्स सो पाई थे से 7p1 a very strange anomaly तापरे स्टेप स्टेप कथा मु ऑलरेडी कहिची एस ब्लॉक पी ब्लॉक कथा मु ऑलरेडी कहिची डी सीरीज 3d सीरीज 4d सीरीज 5d सीरीज एटा सब जानिछ एटा सब नेचुरल मु ऑलरेडी कहि सारलेनी देयर आर लॉट ऑफ कंट्रोवर्सी के 86 टा कहंती एक्सक्लूडिंग रेडॉन आल्सो इज रेडॉन एटा एक्चुअली रेडॉन टा वर्तमान मु लिखि परिबिनी काहे कि रेडॉन अबंडेंस वर्तमान बढ़ी चललानी 87 जगह जाई परिबा फ्रांसियम एस्टेटाइन पोलोनियम को जदी माइनस करबा बिकॉज़ दे आर स्केर्स 90 मध्ये कहि परिबा किछि बहिरे टेक्नीशियम प्रोमेथियम को खाली दीटा को जदी हमें माइनस करबा किंतु मु 94 कहबी कहना नेपटुनियम प्लूटोनियम were also there now scarce they are there in trace quantity now so it already koriche and there are many stable elements who have their brothers some isotopes which are radioactive like potassium 39 the most abundant more than 99% is 39 is stable but potassium 40 is a beta emitter radioactive carbon 12 13 they are stable but 14 which is in a trace quantity naturally is radioactive beta emitter something so I have given the names English names and the gaseous elements solid elements and these things how they're originally called natrium, hydrazinium for mercury, calcium. Nowadays, more and more English, in stock notation, we are not using these Latin names. They are, everywhere politics is there. They are eliminating the use of course, they have to write Na. Na टाको change करिए हले लोक पागल होई जिवे Na has come from natrium ताको किछ कहि होबनी किंतु लिखिला बेलको सोडियम हम लिखुचे natrium लिखुने सेमती कहूची फेरस सल्फेट को होतला नो आयरन 2 सल्फेट टीन स्टानिक क्लोराइड को होतला नो टीन 4 क्लोराइड प्लम्बस प्लम्बिक नो कि lead 2 सल्फेट lead 4 सल्फेट एमती आसी गलानी प्लम्बम आउ नाही सेमती gold 1 nitrate gold 3 nitrate The modern periodic law, therefore, was changed from atomic mass to atomic number. Physical and chemical properties of elements are periodic functions of not their atomic masses, but the atomic numbers. Transition series also, series-wise also, we have a melody for that, anomalies, bridge. What are bridge elements and typical elements? Group 2 and 3, they are group 2, sorry, period 2 elements, starting from lithium to neon, they are called bridge elements because they have diagonal elements in third period. Typical elements, third period elements from sodium to argon, they are called typical elements. And diagonal element relationship, not elements. लिथियम रू स्टार्ट है तार डायगोनाल अच्छी लिथियम टा पीरियड 2 रे पीरियड 4 रे होची पीरियड 2 रे पीरियड 3 रे होची मैग्नीशियम ता डायगोनाली लिथियम मैग्नीशियम बेरिलियम एल्युमिनियम बोरॉन सिलिकॉन कार्बन फास्फोरस इमानकर किछि कॉमन सिमिलरिटीज इन द फिजिकल प्रॉपर्टीज केमिकल प्रॉपर्टीज रहउची ताको कोते डायगोनल रिलेशनशिप हम पढिबा डिटेल पढिला बेले लिथियम संगे कोन मैग्नीशियम रो सिमिलरिटी रहउची हम पढिबा अच्छा आगुरु जेतेबेले बाहरी नथिला से सब ना दिया होता लैटिन नेम नील माने 0 ऊन माने 1 बाई माने 2 ट्राई माने 3 क्वाड 4 पेंट 5 हेक्स 6 सेप्ट नॉट हेप्ट सेप्ट 7 ऑक्ट 8 एन 9 लास्ट को ईएम लगे फॉर एग्जांपल नुआ एलिमेंट तैयारी हम 119 एबे तैयारी है नहीं 119 ता ना कौन हम ऊन ऊन एन ईएम यू यू ई ऊन एन माने 9 ईएम लागू लगे तो आगुरी आज पर्यंत बहुत गुड़ाक ना दि जा हास्यम जो ना दिहबा ता पूर्व ता ना थिला डिस्कवरी होता कि बाड़िया पिटा होकर ना दिहई नाला तेणु तापर से बसिक फाइनालाइज कले केतबेले 3टा ग्रुप तो जर्मनी रे गोटे ग्रुप अच्छी आउ अमेरिका रे गोटे ग्रुप अच्छी आ गोटे रशिया रे गोटे ग्रुप अच्छी ये 3 जन भितर गंडगोल हे सी कह मु बाहर कर आग मोर स्ट्रीट मोर साइंटिस्ट ना करा जाऊ सी कह एमती फाइनाली डिसाइड होकर ताकि तो आगुरी आम पढ़ाऊलू कौन ना 108 को पढ़ाऊलू ऊन नील 0 माने नील ऑक्ट इयम ऊन नील ऑक्टियम तो सेमती आजिकल ना केवल गोटे हम जोटा से मुझे दैट इज द एंड ऑफ टुडेज क्लास आम पीरियडिक प्रॉपर्टीज काली आरंभ करवा नेक्स्ट क्लास एबे भावुली आज गोटे पीरियडिक टेबल पीरियडिक प्रॉपर्टी सेटा हूँ इंपोर्टेंट जोड़ा हूँ एटॉमिक साइज टा से आम बहुत जिनस पढ़ा स्लेटर्स कैलकुलेशंस पढ़ा हाउ टू फाइंड द स्क्रीनिंग कांस्टेंट यूजिंग स्लेटर्स theory and then we find the effective atomic number effective nuclear charge ENC Z star Z is the an atomic number or the actual nuclear charge but we have to find out the effective nuclear charge using the screening constant sigma subtracting sigma from the nuclear charge or the atomic number you get the effective nuclear charge and through that effective nuclear charge Z star we can explain many periodic properties like atomic size then ionization enthalpies electron gain enthalpies or electron affinities electronegativities and other melting point boiling point so many densities atomic volume many properties can be explained through the concept of effective nuclear charge anything you want to ask आज गोटे धरले सरी पारिबनी कहीं बेकार ताकू स्टार्ट करबा सो आज हला को बार आज हला टुडे इज थर्सडे सॉरी सैटरडे तो मोस्ट लाइकली हमें मंडे दिन ही हमें करबा एटा को मु बहुत फास्ट चलेली कोन पई बिकॉज आई अंडरस्टैंड दैट यू हैव वॉच्ड और अटेंडेड माय क्लास सो मु जोरसोर चलेली तमे आउ थरे किंतु स्वयं एंड ये तमे निजे पुणी जेमती आमे कले सेमती निजे ड्रॉ करी एलिमेंट गुड़ाक लिख एटॉमिक नंबर गुड़ाक जनरेट कर एंड देन लैंथराइड्स एंड एक्टिनाइड्स मध्य लिख स्टेप दब सो दैट मुझे तुमको पचारि क्रिएट इन 2 minutes संगे संग मु आगे देखब देखी तुमको सर्ट कि मत देखेब खोलिकी सर मुझे करदे 2 मिनट भितर से दैट शुड बी द प्रैक्टिस So yes, see you on Monday. आज Friday ही था प्रकृत रे because class 12 रो मध्य क्लास चली छी तमरी भलिया जड़े अच्छी तमर बेले जड़े यूरानियम रो पिला जड़े आउ जो इंग्लिश मीडियम रो मोर गोटे नातुणी पढ़ुची नातुणी सब से କରୁଛି ଆଉ 2 ଜଣ ଭଲ କରୁଛନ୍ତି କିନ୍ତୁ ସିଏ ସବୁବେଳେ ଟପରେ ଅଛି ରୁଦ୍ର। ଏମାନେ ଆଉ 3 ଜଣ ଝିଅ ଅଛନ୍ତି ଆଉ ଆଉ 2ଟା ଖଣ୍ଡେ ପୁଅ ସେମାନେ କେତେବେଳେ ଆସିଲେ କେତେବେଳେ ନ ଆସିଲେ ତାଙ୍କର କିଛି ଠିକ ଠିକଣା ନାହିଁ। ଓକେ ଦେନ୍ ବାଏ।
Thank you, sir.